Hey everybody, welcome back to the 3D Printing Corner. I'm Jason, and today we're going to be talking about Proto Pasta's filaments, particularly their filled filaments. I've gotten some samples of the Proto Pasta specialty filaments, half a dozen of them here, and we're going to cover them one by one. So what I want to do first is talk to you about my print settings. So I talked to some of the folks at Proto Pasta, and they told me that their filled PLAs, they want them to print like a standard PLA. So I printed all of these with my standard PLA settings. So I just wanted to talk about what those are. Every one of these is printed at a 0.1 layer height. The reason I use that 0.1 layer height is I wanted to give all of these the best chance of coming out as a nice smooth print as I possibly could. My extruder was run at 205 degrees. I run a Micro Swiss all metal hot end with a plated brass nozzle. Now that plated nozzle is going to be very important for most of these. They're filled, some of them with metals, others with carbon fiber. If you run that through a standard brass nozzle that is not plated, or else not a steel nozzle is another option, it's going to wear that brass down incredibly quickly. So next thing you know, your 0.4 millimeter nozzle is now a 0.6 millimeter nozzle. You're not going to get as good a print. So these, I've heard some people telling me as little as a couple hundred grams of carbon fiber run through your brass nozzle will basically destroy it. I do print on a standard BuildTak-like surface that comes with the Maker Select Plus. I'm printing with Z-braces. I do have my spool mounted on top. And I am, like I said, running that Micro Swiss all metal hot end with a slightly customized cooler, but nothing out of the ordinary. I run the fan 100% after that first layer. I don't run any fan on the first layer. I printed all of these at 100% flow, 60 millimeters per second with a 0.8 millimeter top, bottom, and sides. I run at 20% infill. I use triangular infill. And I run 6.5 millimeters of retraction at 25 millimeters per second. Like I said, those are my standard PLA settings. Your standard PLA settings are obviously going to be different. You may not have this exact same printer. Even if you do have this same printer, we all know, printer to printer even can vary what your standard settings are going to be. But those are mine. And yours are probably a good place to start with these filaments as well. So the first one we're going to talk about is coffee PLA. Yes, coffee. It does smell like coffee. It's a pretty smooth filament. It feels a lot like normal PLA. Nothing really out of the ordinary with it. It's a little bit stringy. Which could probably be fixed by playing with my retraction settings and my temperatures. It printed with no warping at all. It stuck right to the BuildTak bed. Nothing to it, just like normal PLA would. It does smell like coffee. When it's hot and printing, my basement here, which for those of you that don't know, the corner is my corner of my basement. It smelled like coffee for the whole time it was printing, plus several hours after. And it's not that early morning, fresh first cup of coffee in the morning. It smells more like that cup of coffee that you put on your desk at 8 o'clock in the morning and forgot about it. Now it's noon. It smells like a little bit more like old stale coffee. One of the things they say on Proto Pasta's website is it's not the top grade coffee, it's just really good filament. I would agree with that. It's not the most pleasant smell. That said, if you really like this color and this is the color you're looking for, it prints pretty well. It's got a little bit of blobs at the layer changes, but nothing that you couldn't smooth out relatively easily with a little bit of sandpaper. Little bit of stringing in between the letters here on the maker coin. But for the most part, it prints like you would expect PLA to print. It expects like you would expect nice PLA to print. The next one we're going to talk about is their magnetic iron PLA. Now this one, I thought it was kind of cool. It didn't string at all. There's absolutely zero stringing between these letters. No warping. It's stuck right down to that bed. It's flat as can be. Interesting thing is, I know that in a standard PLA, my maker coin weighs about 10 grams. Usually it's pretty spot on from brand to brand of PLA. It's about 10 grams. This one weighs 14, so it's about 40% heavier than standard PLA. One of the cool things about it is it's got enough iron in it, it's actually magnetic. So there's a magnet stuck right to the back of it. It's not stuck super strong, but it sticks. I've been trying to come up with what would be a great use for this stuff. And I haven't come up with one yet. If you've got any ideas, comment below, let me know. It doesn't print perfectly smooth. It doesn't, it blobs a little bit at the layer changes. Again, we could probably play with our settings and fix that. But it prints overall really nice, and it's got some interesting characteristics. One of the other things that it can be done with it is, anybody that's seen Joel Telling, the 3D printing nerd, he printed a TARDIS out of this and actually rusted that TARDIS. There's enough iron in here that it can actually be rusted. So that's something that's kind of cool about it. To me, I think it's maybe more of just a novelty type item. But like I said, if you can think of anything, comment below, let me know. The next one is probably going to be one of the more useful of all of these. It is matte fiber HTPLA. So essentially it's an organic fiber that is filled into the filament while it's being made. I picked a nice red. It comes in several colors. This print's fantastic. No stringing at all. There's not even a single speck of a string flowing from a point to the middle, or the middle, across the letters. There's not a string on here. It's PLA. It is a filled PLA. It's filled with an organic fiber. But it prints exactly like you would expect PLA to print. Now, it does feel a little strange. The same as actually the iron is very similar. It's not smooth. It's a little bit rough. If you think about, which is kind of ironic since it's Proto Pasta, a piece of raw spaghetti. It feels that just a little bit of roughness to it. Excuse me. But all in all, it printed really nice. It feels like it's going to be brittle when you get it out of the package. It's not. It was very flexible. It was easy to load into my extruder, and it just printed. This is probably, if I needed something a little more high temp resistance, but yet doesn't require the ABS or the PETG type option for temperature, I might give this stuff a try. One of the neat things about it is this can actually be annealed as well. For those of you that don't know, that's essentially you're going to set your oven to a relatively low temperature. I have not tried this yet to be sure how it's going to work. We'll get to that maybe in a couple of weeks. Put it in the oven for a while and it will actually get stronger. Now, one of the things I've heard that will happen with it is it will shrink a little bit too. So that's going to be a problem with trying to make dimensionally accurate yet stronger parts. But I've heard the shrinkage is relatively predictable, so maybe you can design it into your part. But all in all, this printed very nice. Like I said, it didn't warp at all. Again, it's perfectly level on that bed. Stuck nicely, but freed up as soon as it was cool, no problems. It's a pretty good filament. It actually worked really nice. The next one we're going to talk about is carbon fiber. Now, this one also had that same kind of dry texture. This one was a little bit more brittle. It did snap on me at one point, just trying to load it into my extruder. I probably put a little too much force on it in some direction or another, and it just snapped, and it was not a big deal. Just pop it out, put a new one in, put a new end in. all in all, it's a nice matte black. It tends to blob up and at this one I actually did play with the settings a little bit, but it just seems to want to blob up a little bit at the layer changes. This is also one of the only ones that I had warping issues with. These little points, the reason I put these little points on the edges of this is they're points that have a little bit less surface area, and if it's going to warp, it's going to warp there. All of these were printed, no brims and no rafts. These were all printed straight onto the board. I did throw a skirt around them just to get a nice prime on the nozzle, but nothing touching the print. And this is one of the only ones that warped. It wasn't bad. It was not stop the print bad. It warped, a millimeter or two up on a couple of the corners. Not that big a deal. The print just goes on. This one does not have a smooth finish. All in all, it doesn't print great. It prints okay, but not great. I would say that the thing this has going for it, and I have not tested this again yet, again, we'll get to this in a couple of weeks, is supposedly this has some extra strength properties. So we'll try and see just how much stronger this is in a couple of weeks. So if you maybe needed a part that you didn't really care if it was necessarily pretty, but it was going to be functional and needed to be a little stronger, maybe the carbon fiber is going to be the way to go. So the next one we've got stainless steel filled PLA. This one, I was blown out of the water. This one's fantastic. The filament itself is, again, that little bit of a roughness to it, not that typical smooth plasticky PLA. It's heavy again. It's very much like the iron. It's actually about the same weight as the iron PLA, so it's going to be about that same density. It just printed. It's got a purpose. So it's a really nice, pretty color. I actually really like this gray. I really like the feel of it. It feels, it's not smooth, but it's also not rough. It feels that like you can't really feel the layer changes. It's just that the filament itself has a rough, nice matte texture to it. Again, though, that's not the purpose of this one. The purpose of this one is, and as much as I love this color, you can polish this. I haven't tried it yet. We're going to do a video here in the next couple of weeks where we're going to go through all of these filaments and try them out for their quote-unquote intended purposes. So we're going to try and give this one a polish here in an upcoming video. But I have seen people that put a polish on, for instance, a printed ring. Things like that. And they look nice. They're not... Don't think about it like polishing a piece of stainless steel where you're going to get a mere finish. You're just going to get a nice shiny surface to them. So we'll give that a try in a couple weeks, but all in all, between this one and the matte fiber HT PLA, these were probably my two favorites to print. They printed beautifully, they printed easily, they printed at my normal settings. They just printed. Now the last one we've got to talk about is the one that actually a lot of people are the most curious about, conductive PLA. Unlike all the others, this one's a lot smoother. It actually feels a lot more like this, this is just a standard PLA. It feels a lot more like this does. It's actually even smoother than that. Which made me think when I was getting it out of the package, wow, this one's actually going to be the least brittle of them all, which turned out to be completely wrong. I snapped that one as soon as I tried to put it in the extruder. This was the first print that I ran with it. This is the bottom layer. There's the top layer. You notice it's not finished. That is because I went to work, and at some point while I was gone, the PLA itself snapped right here. It finished running through and printed air. So obviously came home, failed print. That's never fun. So I thought, well, I'll try it again. So I printed this one. Now this one did complete, but you should also know I happened to be home while I printed this one. And I also happened to be in this basement while I was printing this one. So when the filament snapped on me again, it snapped about right here again. I was able to pause the print, pull out that piece of filament, and reload it and let it finish. So all in all, I snapped this one 3 times. So this was by far the most brittle of all of them. All of these were vacuum sealed. When they came to me, they were all the vacuum was not broken on any of them. I broke the vacuum on every single one of them when I opened them up. So that tells me that either A, it's a more brittle filament, or B, it was exposed to possibly some different elemental things, more moisture, less moisture, something in the factory. I don't know. All I know is the results for me, from my samples, it was the most brittle of them all. It had a little bit of warping when I did get it to print, nothing bad. It had a little bit of blobbing at the layer heights, nothing bad. It was harder to print than standard PLA. But again, it wasn't bad to print with. The printability of all of these is pretty nice. But this one just, it didn't print as well. It's got some over extrusion issues that I can actually see in the print. It's got some under extrusion issues that I can actually see in the print. Dimensionally, I've kind of run calipers along the sample. It's dimensionally accurate, so I haven't really figured out exactly what's causing those under and over extrusions in the same print, but I'll keep playing with it maybe and see what I can find. That said, this filament is not meant to print maker coins. This filament is meant to print things that need conductive filament. So let's just say one of the things people use it for is they print little caps for their 9-volt batteries that have an LED attached to them. A little LED flashlight. Styluses for your phone or tablet. Things that need just a little bit of conductive, a little bit of conduction in order to use them. It is not conductive enough. Like, you're not going to be able to print a circuit board with this, even if you had a dual extrusion and you wanted to print this as like the traces running through a circuit board. It's not going to work. Proto Pasta, from what I'm told, is looking at making a more conductive and a less conductive version of this. But as of right now, they have conductive. That's it. But we'll try that one again here in the next couple weeks. We'll try and print something that actually takes advantage of the conductive. So that's the half dozen Proto Pasta filaments that I tried. All in all, none of them were terrible. A few of them were better than others, but I like the Proto Pasta filaments. They all have a purpose. So there's a reason for them. It's not just throwing, coffee, maybe. But for the most part, there's a purpose to them. They're to make it stronger, they're to make it magnetic, they're to make it polishable, conductive. There's reasons behind what they're putting in the filament. It's not just about the looks, it's about the actual functionality. So all in all, I would definitely, if you're interested, recommend them. They're making a great product. The nice thing is, the way I did this was I actually got samples. They sell 50-gram samples on their website. They ship relatively quickly. I ordered them on a Wednesday, and I had them by Monday. So they ship relatively quickly. And their samples are relatively inexpensive. They're about anywhere from $4.50 to about $6.50 for what they call a 50-gram sample. Now, I got about the same length of each filament, just visually looking at them. And that means that the metal-filled ones, so the stainless steel and the iron fill, actually are more than 50 grams worth. So they're working more off of length than they are off of weight, which is nice, because then you get enough that you can do some things with it. But all in all, yeah, great products. So if you guys liked what you saw today, I do have some more videos lined up. Click subscribe, it's down below. Come back and check. Here in the coming week, we're going to be experimenting with Budget filaments. I've got a whole stack here. I am going to go over each one of these filaments are under $18. Some of them, such as this white right here, I picked up for $9. And we're going to see, are they budget or are they not worth the headache? So tune in for that. That'll be in this coming week. Week after that, we'll probably be going through each one of these Proto Pasta filaments again, except this time we're going to test them out for what their intended purpose is. We'll probably skip the coffee PLA because it's PLA, it smells. That's basically its purpose. But as far as the iron, we're going to try and rust it. We're going to see how well it sticks things together. I'm going to go ahead and I'm going to anneal that matte fiber PLA and see, does it really get stronger? The carbon fiber, we're going to test it. We're going to see, is it really stronger than a standard PLA print? The stainless steel, I'm going to try and go through and give it a polish and see how shiny can we really get it. And the conductive, I'll probably print out something that needs a slight conductivity and see, does it actually conduct like we would expect it to? Maybe take a few measurements, see, does it actually have the resistance that they say it does on their website? So if those things interest you, like I said, subscribe down below. Let's get that number up there and let's see what we can do. We can all be making things together, and if you've got any comments, definitely leave them below and I'll get to them as soon as I can. Thanks a lot, everybody. Have a great weekend.